Another important function which we need to learn about is the cumulative distribution function. Sounds rather serious, doesn't it? It's very closely related to the probability density function because it is simply the antiderivative. So f of x is the probability that our observation is less or equal x. And then it is the integral from minus infinity to x of our probability density function f of s ds. Let's go back to our soil example from the previous video, where we had a probability density function of 192x times a half minus x squared. And this was the probability to find a nitrogen concentration in a certain interval. So the question is now to find the cumulative distribution function in this example, and then plot the two functions. Let's do the first step first and determine the cumulative distribution function f of x. So what was it? F of x was the integral from minus infinity to x of f of s ds. Again, our function was only defined between 0 and 0.5. So we don't worry about minus infinity here. We can just go from 0 to x f of s ds, but we require that x is less than 1/2. So we integrate from 0 to x the function 192, but now x is s. So s 1/2 minus s squared ds. I call the integration variable s, but it is still the same integral we did before in the previous video. So I can move to the step where I found the antiderivative already. This was x squared eighths minus s cubed thirds plus s to the 4 quarters between 0 and x. So we get 192 times x squared over 8 minus x cubed over 3 plus x to the 4 quarters. Yeah, if we sub in 0, we get nothing. And then we can multiply in the 192. So we get 24x squared. And 192 divided by 3 is 64. So 64x cubed. And if I divide that big number by 4, I get 48x to the 4. And now there's a common factor if you want to make it really beautiful. So you factor out 8x squared. And then the first one is a 3. And you get minus 8x and plus 6x squared. This is our cumulative distribution function f of x. 0 less or equal x less or equal 1/2. If x is less than 0, then the function is 0 because the density was 0 anyways. But if it's bigger than 1/2, the function is equal to 1. Then we have f of x to be actually 0 for x less than 0. And we have this formula for 0 less or equal x less or equal 1/2. And then we have it to be 1 for x to be bigger than 1/2. Now let's check on the 1 here. Let's take the function and just sub in 1/2. X is 1/2. So what do we get? We get the 8 divided by 4 in the front. And then we have 3 minus 4. And then there is 6 quarters. So 6 quarters, say. So this is then equal to 2 times, you get a minus 1. And then this is a 3/2. So then we have 2 times 1/2, which is 1. Let's plot the two functions. So here on top is the probability density function. On the bottom is the cumulative distribution function. So how are they related? Well, for example, if I pick a value of 0.1 here, and then the cumulative distribution is just the integral of this area. It's the integral from 0 to 0.1. And so this will be this value of the function. Okay, if I integrate further, for example, to 0.2, then I get this area, right? So then this whole area will be indicated here at the point 0.2. If I go to 0.4, I get a whole bunch of area. So this then turns out to be the value here of this function right there. Okay? And if I take the entire function, then the integral integrates to 1. Now we really need to find out what's going on. I bet you Tolo is involved. Tolo, what's up?
There's a 51% probability that I find the treasure right at this spot. Let me dig on.